All right, on tonight's episode of Python Poppy, we're back inside our artificial intelligence course, and we're still doing our neural networks module. Let's have a look at what we went over tonight. Now, last night, if you recall, the last thing we went over was the hypothesis function, and tonight we're going to pick up what we left off. So you see here we have our hypothesis function here, x1, x2 equaling g. G is going to represent our activation function. And then we have our weight 0 plus weight 1 times x1 plus weight 2 times x2, or input 1 and input 2. We're going to instead represent this mathematical idea graphically by using a structure like this. This is the structure we're going to use here. So here's a neural network that has two inputs that we can think of as x1 and x2. This is our x1 and x2. And one output that we can think of as classifying whether we think it's going to rain or not rain, for example, in this particular instance. So this is the output here we're classifying where we want to figure out if it's going to rain or not rain by the information we get from input 1 and input 2, or x1 and x2. So how exactly does this model work? Each of the two inputs represents one of our input variables, x1 and x2, and notice that the inputs are connected to the output via the edges, which are going to be defined by their weights. So here we see we have our two inputs here, x1, x2. These are our edges that connects to our output. And you see our edge has a weight 1, and this edge has a weight 2. And then we have our bias here as weight 0. Activation function that adds all that together or gets applied to the function, weight 0 plus weight 1 x1 plus weight 2 x2. So these edges each have a weight associated with them, weight 1 and weight 2, like I just said. And then the output unit, what it's going to do is going to calculate an output based on those inputs and based on those weights. This output unit is going to multiply all of the inputs by their weights and then add in the bias term, which we can think of as an extra W0 term that gets added into it. And then we pass it through an activation function, like I just explained to you. So we have our two inputs being connected to the output by the edges. The edges both have weights, weight 1, weight 2, and then we have our bias, weight 0, get passed through the activation function, which is represented by G. And G actually, or the activation function, is the one that actually calculates all of this for us and gives us an output, gives us this output here. So that is just graphical and representing the same idea we just saw, just mathematically. And we're going to call this a very simple neural network. And we like for this neural network to be able to learn how to calculate some function. We want some function for the neural network to learn, and the neural network is going to learn what should the values of weight 0, weight 1, and weight 2 be. What should the activation function be in order to get the result that we would expect? We can actually take a look at an example of this. What then is a very simple function that we might calculate? Well, if we recall back from when we were looking at propositional logic, one of the simplest functions we looked at was something like the OR function. This is our OR function, and this is what we call the truth table. So we see we have two inputs, x and y, and then we have a function of outputs of x and y. So this function takes in two inputs, x and y, and outputs 1, otherwise known as true if either of the inputs or both of them are 1. So you can see here we have three ones at the end. That's because the last three inputs here have a 1 in them, 0, 1, 1, 0, and 1, 1. Outputs is 0, otherwise known as false if both the inputs are 0. As you can see here, we have a 0 for the first one because both the first inputs are 0. And those represent false and true. So this is the OR function, and this is the truth table for the OR function. As long as either the inputs is 1 and the output is 1, and the only time the output is 0 is if both the inputs are 0. So the question is, how can we take this and train a neural network to be able to learn this particular function? What would those weights look like? I'm going to stop it there for tonight. We did take a lot more notes, and we did do a lot more graphing and a lot more modeling, but I'm not going to dive into everything tonight. But of course, I will keep you guys posted every step of the way when we pick it up tomorrow. But for now, this is the Python Poppy. You guys stay Gucci.